A completely different focus in this presentation. What does sustainable chemistry mean? This is the core question. Lots of things are defined and some other things are ill-defined or not defined at all. For instance, product carbon footprint, which is defined in different ways, and with those different definitions you get different data. This is what Peter Thoma will talk about of Zimmer and Schwarz, and I look forward to your presentation. Thank you very much for your kind words of introduction. I hope you can hear me well. We have heard a few presentations which were very nice on sustainability of leather. I would like to give you a presentation on the sustainability of leather and how you can improve that using sustainable chemistry. I would like to make a suggestion, as Mr. Tegtmeier has said, that there are different definitions involved still. The sustainability of leather. I think it goes without saying for all of us that when you take the raw hide, sheepskin or cattle skin, bovine skin, that this is some kind of upcycling. In the past we called it recycling, but I call it upcycling, because we have an even better material. We turn it into an even better material over several hours and days. The skin would degrade, but leather is good for the long term. And given the sheer amount of skins, no other industry would be able to cope with that. We need tanneries, we need the leather industry, because otherwise you would need to dispose of the hides or incinerate them. You see the two pictures. Or what we do, we turn it into a long-term, durable, sturdy material which has top-notch quality as well. So why is leather sustainable? Mr. Autenried has already mentioned it. There is ASTM D6866, with which you can determine the biological carbon in a product. I give you an example here. And why is leather sustainable? When I turn a hide into leather, I don't need alternative products which are made from petrol, so plastic alternatives. So that is one saving. When I turn a raw hide into leather, I reduce organic waste, because otherwise the majority of the skin of the hide would need to be incinerated. So I save CO2 emissions, I avoid CO2 emissions, I avoid contaminating the soil or toxic substances in landfills. As the example shows here, leather, even if you use synthetic retanning agents or fat liquors, it has a high degree and a high portion of renewable carbon. But how can we improve that even better? Namely, with the chemistry we use, with the chemicals we use. We've heard it a lot already. Those are the UN Sustainability Goals, the 17 Sustainable Development Goals, and here you see a few watchwords. This is what we have heard from customers. This is what turned up in surveys or in the press, and I take it you have heard those words, those notions yourselves as well. And I have tried to sort them and put them in a good order, namely high significance or lower significance for leather. Don't get me wrong, I will talk about that later. And how easy, how straightforward, or how complicated such criteria are. So first, lower significance. Here, energy consumption is mentioned. Don't get me wrong, of course, energy consumption is an important factor in the leather production, but you have to see it in context. There are processes which you need, which consume a lot of energy, not for leather, but let's say the furnace process in steel production. You have to have those processes. So you cannot use this as a lever and cannot use it as a comparison among industries. So now high significance, the top ones and the bottom ones, what you see at the top, they are relatively easy to achieve, they are easy to verify, and they are very telling. Mr. Tegtmeier said it at the beginning, carbon footprint, environmental footprint, water footprint, those are important values, but the more important or telling such a value is, the more difficult it is to determine it. Hence, at Zimmer and Schwarz, we thought about this. What are values which are very good for comparison, with which you can compare chemicals in terms of their sustainability? Here, low hazard categories are mentioned, so products with a good rating, which are not toxic. The Association of the Chemical Industry is looking into a definition here, but those are the points which you see on the left, which we've had a look at. Which brings me on to the percentage of bio-based and renewable materials. Why is that an advantage? We consume fewer petrol or petrol-based products. With that, we automatically reduce our carbon footprint. And when you go one step further and conduct an LCA, a life cycle analysis of a product or an auxiliary, you get a better situation when you have bio-based or renewable materials from living nature. But there is a problem which is not solved for the time being. And over the next couple of years and decades, a lot of work will be done in this respect. For instance, fat liquors based on renewables. I think you may get into conflict with food production. So it's a bit of a tightrope walk, a balancing act, whether you can branch off material flows from the food industry so that you don't get into conflict. How can I determine those values? We have heard about ASTM D6866 analyzing the C14 content in total organic carbon, and there is the DIN EN 16640, or rather the other one is 16785, where a material balance method is used to calculate the renewable content. So not just carbon, but all chemical elements, all renewable chemical elements. For instance, if I dilute a product with an inorganic salt in the ASTM, you wouldn't be able to tell, but in the DIN 16785, it would crop up. You need to do some work, and for the 16785, you need to have sound knowledge about your raw materials so that you can do the calculations. And another point, there will be a good presentation about this later on by TfL, about biodegradability or degradability as such. The advantage is, if I have a look at that in terms of sustainable chemistry, if a chemical is biodegradable, after wastewater treatment, I will have fewer residues, less residue in the water as well, in the water which is released into nature after wastewater treatment. And even If in the industry and the tanning industry there is no downstream wastewater treatment, if I have well-degradable chemicals, I have an advantage, especially when the wastewater is released into nature untreated. But there is a but. I can have sustainable materials, I can take natural and sustainable materials, but they can still be difficult to degrade. For instance, vegetable tanning agents, which are difficult to degrade because they are to stabilize leather. There are several methods. We have heard about the OECD methods. Here measurements are done, tests are done for 28 days, but you can pursue a simpler way. You can have a look at the chemical and biological oxygen demand, compare them, and within 5 days you will have a very good comparability and a good way of assessing and evaluating the products. And another point, which we have included in our proposal, products with a high water content are worse compared to products with a lower water content. The more water there is in a raw material, in a commodity, the more water is consumed. When you produce this product, I have to ship around the water. The water will be in my tannery. It's not an active substance. It doesn't do any fatting, doesn't do any retanning, no retanning effect. I just ship around water, I lug around water, and when I take more concentrated products, I have less water in the tannery, depending on the product, of course. And if I have less water content, I have lower transport costs, lower shipping costs, and in the long run, I have a smaller CO2 footprint because I ship around more product but less water. A few examples next. You see a few examples without giving you any names of vendors, just to show you what we have in the market at the moment. There are products which have a sustainability label. They say they are eco-friendly. And as I said at the beginning, at the moment a lot of words are bandied about where there may not even be a good definition for them. When you have a look at this, just two examples, two products which are labeled sustainable and two which are labeled as eco-friendly. And when we just have a look at these three values which we suggest, namely the biocarbon content or the renewable content, degradability, and active matter content, so as little water as possible. You see, there are products which can be labeled sustainable. One example is 88% biocarbon, 52 degradability, and 94% active water, so only 6% water, and underneath a product which is eco-friendly with hardly any renewable content, almost no biodegradability, and only 30% active matter. So this is just an example. You have to take care, you have to watch out. We do this as well. You have to watch out what are the labels which are bandied about, and what do they actually mean. And another example, I have already cited this, two leather samples. again using the ASTM D6866 test, in order to show how I can enhance the sustainability of leather relating to sustainable materials. I compare a fully sustainable leather and another one where synthetic retanning agents and fat liquors were used. And you see almost 100% sustainable. So you can achieve almost 100% biocarbon content. You can even achieve 100. This is just one of our examples. In order to show it to you, for the tanners among you, the tanners who are listening, so that you can see what this is all about. This is the formula for our leather, so normal workflow. We added a sustainable filler compared to a polyacrylate, which is containing non-sustainable materials. Then we used Tara gum and a sustainable retanning agent compared to a Syntan, and two kinds of fat liquor, one sustainable based on sustainable materials and one fossil-based fat liquor. And then we use the normal leather workflow, and you can see the result. On the one hand, you get a good result with leather, but with sustainable, biodegradable products and agents, you can come to some good improvements. Which brings me to the end. By way of conclusion, I would like to say this. Leather itself has a high degree of sustainability already. I think we all know that. But this is something which we need to communicate time and again. The production of leather reduces the use of fossil fuel materials. One problem, as far as sustainable chemistry is concerned, we don't have a hard and fast definition as yet. What is sustainable chemistry? What are sustainable chemicals? But that will develop. This will be with us for years and decades to come, and this is an ongoing process. But our approach is the following: use products which have a lot of active matter, little water only, which have good biodegradability, and which have a high content of renewable bio-based materials. And with that, you have already made a lot of progress. Why is it good to work on such a definition? The three values which are mentioned are easy to verify, are easy to measure, they are clearly delineated, clearly defined. You can easily compare them. Products which you are given can be tested and evaluated in this way, and you get a very good evaluation of the degree of sustainability. Other values like life cycle analysis, CO2 and water footprint, they are also important. We have to do that as well. But for LCA, for instance, I see time and again, for instance, that the carbon or water footprint is included as well, which makes it difficult to compare, and the values are difficult to achieve for the time being. So our proposal is use easily comparable values first in order to make your chemistry more sustainable. And with that, I would like to thank you for your attention, and I hope you will enjoy the rest of the conference. Thank you very much, Mr. Thoma, for this wonderful presentation. And there are two questions. One is about the actual chemistry. I will read it. Less water
and penetrability in the process. Are there any changes?
Das trifft natürlich das Thema der Produktentwicklung.
So this is
Da
to
muss
do
man
with
natürlich drauf
product
achten,
development. You
wenn
have to
ich
make
neue
sure
Produkte entwickle,
when I
die eine höhere
develop, when I
Konzentration habe,
engineer new
dass ich das dann
products
auch
which
noch
have a higher
in der
concentration,
Anwendungstechnik, also wie gut
that
das dann ins Leder
for
einzieht und
applications
meinen Prozess
like
verbessert, das
penetrability,
muss ich natürlich dann noch mit betrachten.
I have to
Also es
consider
bringt
that
nichts
as well.
natürlich
Of
nur
course,
zu sagen,
it would
ich
be no
konzentriere ein
use
Produkt auf und dann funktioniert es nicht mehr.
concentrating
Das ist
on
natürlich ein Punkt, der muss dann
product
in
development and
Bezug mit
then
der
it doesn't work.
Anwendungstechnik mit
But
betrachtet
I
werden.
have to
Genau.
consider later
Ganz
applications as
generell,
well
ich meine,
and test for
wir haben jetzt
that.
von verschiedenen chemischen Firmen Vorträge gehört und wir
From
hören die auch noch heute Nachmittag.
different
Vielleicht eine
chemical
kleine Botschaft an die ganzen
companies
Gerber.
from
Sie
the
sehen, die
chemical
chemische
industry.
Industrie ist
We
sehr
have
aktiv.
heard presentations.
Das ist ein
Let me
wirklicher
say to
Process
our
of change.
tanners,
Es ist nicht
there
einfach
is
ein
a
kleiner
process of
Austausch von
change
einem Rohmaterial mit
among
einem
the
anderen,
chemical
wie
industry. It's
vielleicht
not
auch
just
früher der Fall war,
swapping
wenn
raw
man
materials.
NEP-frei auf wässrig umgestellt worden
For
ist, da hatte
instance,
man einfach NEP raus. So einfach war es auch
in
nicht.
the
Aber
past, it was sort
es
of
ist eine komplexe
NEP free and then
Angelegenheit, der Switch
aqueous,
zu nachhaltigen
but it's very
Rohstoffen. Und
complex,
Ihren
the
Vorschlag,
switch
erstmal diesen ersten
towards
Weg gehen,
sustainable raw
bevor die
materials.
Diskussion,
So
welche
your suggestion
Definition
is
und was auch immer da der
make
KPI
one
ist,
step
man
at a
nachher
time,
nimmt, ist mit Sicherheit ein
look
sehr
at
guter. Auf der
the
anderen Seite glaube ich,
KPIs
sollten wir uns in der chemischen Industrie auch sehr stark
in the
zusammentun und
chemical
vor allen
industry.
Dingen, an
We
diesem Prozess der Definition
huddled together
mitprobieren, damit er
and
nicht der
worked on
Lederbranche zum Nachteil
definitions
wird, ne?
so that
Dafür
it
sind die
wouldn't become a
Kommissionen ja gut
disadvantage
da,
for
die
the
wir
leather
haben bei
industry.
TGEVA
For
und hier
that,
auch beim
we have
VGCT.
good committees
Ich
at
denke mal, das sollte ein Schwerpunkt
VGCT
werden
or
in den
TGEVA.
nächsten
And in years to come, we
Ja,
should
dann ist noch
concentrate
eine
on
andere
that.
Frage.
And there is
Is there
another
any other
question.
sustainable alternative for rawhides rather than producing leather? Klar, das ist eine Frage, die von Kunden kommen wird. Ist jetzt nicht eine direkte Frage. Ich weiß nicht, ob Sie das mit einem Satz
Customers
kommentieren
will
wollen, beantworten,
ask
wird man
that
die
as
können.
well. I don't know whether you can answer this question.
Es ist, denke ich mal, auf dem Weg. Da wird es bestimmt in Zukunft interessante Materialien geben.
There will be
Aber ich
interesting
sehe da auch
materials
momentan
in the
noch
future,
keine echte Alternative,
but I
die
don't
auch
see
wirklich
any
die Langlebigkeit
alternative
nicht nur dann auch, also die Langlebigkeit, sondern
which
auch
would provide the
gerade
same
im
kind of longevity,
Bereich
for
hier
instance, in the
oder im
automotive
Bereich
industry
hier
or
auch
for
die
furniture,
Ansprüche erfüllen.
and
Das
which would
muss
have
man,
the
denke ich,
same
im Auge
quality.
behalten.
But
Also,
I think
und da
we
wird
have to
was kommen.
consider that, and there
Jetzt
may
nur von
be
der chemischen
ideas,
Sicht ausgesehen, nicht von der Gerberei-Sicht ausgesehen,
not just from a
ist es schön,
chemical
wenn da
or
auch
tanning point of
Alternativen
view.
kommen.
Of course, it would be nice to have
Aber das
alternatives,
Thema Leder
but
und
leather,
das ist etwas, was uns begleitet, weil, wie gesagt,
this will
ansonsten
be
haben wir
with
da einen
us.
großen Müllberg irgendwann.
Because
klar.
otherwise
Ja,
we
es
would
ist die
have a
Frage, ne?
huge
Darauf
mountain
geht's
of
hin. Kann
waste.
man nicht irgendwas
This
anderes
is what this
Sinnvolles
question
mit
is
den
getting
Häuten
at.
machen, außer
Can't you
Leder
do
herstellen? Das ist eher
anything
so die
that
Richtung.
makes
Und
sense?
es gibt ein
And
Kollagensymposium
not
hier
just leather.
beim
There is
Filk-Institut,
a
was sich
collagen
wissenschaftlich und akademisch genau
symposium
mit dieser Frage
at
beschäftigt,
Filk,
was man noch
which
alles machen
will
kann. Es
look
gibt viele
into this
Lösungen,
matter.
Dünger
There are
und
lots of solutions, fertilizers,
Kollagenindustrie,
the collagen
aber
industry.
ich meine, 300 Millionen
But
Häute pro Jahr, das ist ja ein
300
gigantisches
million
Volumen.
skins
Und
and rawhides a year,
von
that is
daher
some huge
glaube
volume.
ich, kann man die Frage im Grunde schon so
So I
beantworten.
think you
Diese
can answer that
Riesenmasse an
question. This
Rohware,
huge
zur Verfügung
amount
steht,
of
da gibt's
rawhides
nicht so
which
schnell
we
ein
have,
einfaches,
it would be
alternatives,
difficult to find an
sinnvolles,
alternative
Produkt
that
für,
would
ne?
make sense
Und
other than leather.
da ist Leder einfach die Methode
So
der Wahl.
leather
So sehe ich
is your
zumindest
method of
auch.
choice, as
Kann
far
ich
as
nur
I'm
beipflichten,
concerned at least.
absolut.
And
Dann
I agree, Mr. Thomas
können wir die
says.
Session